All right, so let's do tangents of a circle. So if anybody's actually watching this on YouTube, I don't have section 8.1 up there because I was absent that day and I showed the video from last year. So I kind of scanned through the video from last year, and yeah, I covered all the points that I needed to, so there was nothing missing. So if you didn't watch it, make sure you watch it, okay? But it won't be in this year's playlist because I'm not going to teach it again just to put it in the playlist. It's from last year. So here we go. Let's do this. Again, this whole chapter is about circles, all right? And this is a tangent of a circle. Have you ever heard the word tangent before? You've never heard anybody say the word tangent? Like I do this once in a while. I don't do it as much as I used to. I used to do it a lot. But I would start talking and students would try to get me to change topics, and it happens. You've done it, right? And I realize it happens. It's not like I don't realize what's going on, but I'm fine with it. But people would say, "Oh, Mr. Hamrick went off on a tangent again today." Has anybody heard that? Okay, it just kind of means they went off in another direction, right? So I was trying to go this way, but now I went off in another direction. And it's kind of what this is on a circle, okay? Kind of. So anyway, you have heard the word tangent before, but you probably have never heard it in concerning math. There's another, and I think after this chapter, we may skip all the way up to chapter 12. I got to look at the calendar and see, because we're going to do trig. I've talked about that before, right? Trigonometry. And in trigonometry, there's a thing called a tangent. It really doesn't have anything to do with this tangent. It's completely different, but same word, same spelling, all right, but it's a different concept. So we're actually going to talk about two different tangents this year. This is the first one, all right? And so let's do this. Let's make a circle. I remember back in the day when I used to teach on a chalkboard. Have you ever learned from a chalkboard? Actual chalk? You never have? So, you know what a chalkboard is, though, right? You know what chalk, and it's all dusty and stuff. And usually the boards are green. They used to be black. They used to call them blackboards because they were black. But then they turned them into green. I don't know why. Maybe it's a better material or something. I'm not really sure. They never called them green boards, but they call them chalkboards. And I'd always have a difficult time making a circle because it was so hard. I saw a video. I think a kid told me years ago before the internet that their teacher could make a perfect circle. So he said he held his hand like this and he just drew it, I don't know, made a perfect circle every single time. So I tried. I've watched some videos where teachers do that. I don't think I've ever made a perfect circle. No, I'm not. I just made a perfect circle. It's right there. All right, but I got a computer program to help me out. So that is a perfect circle. Let's talk about this. Let's talk about two words, and we're just going to kind of camp out on one of the words. The other word we will talk about at another point, but not today. So what if I drew a line and it went through the circle and it hit the circle at two places on the circle? When we talk about the circle, when I say on the circle, I'm actually talking about the white line that's going around, okay? A lot of people think the circle is like a disc, right? And this is on the circle. Right? Like a frisbee. Like I throw frisbees for disc golf, all right? It's a circle. The place, this area right here, a lot of people think it's the circle, but it's not the circle. The circle is the outside edge of it right here. This would be what? If I put a point here, it would be where in comparison to the circle itself? It would be, if I put a point here, I could describe that. If I put a point here, I could describe it. If I put a point right here, I would say that this point right here is on the circle. Okay? Well, where would this point be? In the circle. That's right. This is inside the circle or the interior of the circle. Where would this point be? Outside the circle or in the what? Exterior of the circle. Okay? Everybody got that? All right. So when I talk about on the circle, because a lot of students get confused about that sometimes, on the circle means actually the edge, the curvy part to it, okay? That's the circle. So if I had a line, it could be a line segment as well, but we'll just say line. If I have a line that actually goes through the circle and it hits 2 points on the circle, all right? So it hits right here and it hits right here. We call that, I'll put a little arrow right there, we call that a secant. That's another thing we may talk about. I don't know, actually maybe in your class we may not talk about secants in trig. We might just do the basics. But the secant is actually the inverse of the cosine. Have you ever heard of cosine before? Sine, cosine, tangent. These are all foreign words to you or not? Anyway, it's fine. It's no big deal. I mean, I would not have expected you to learn that before this class, okay? This is probably the first time that you would have ever heard of sine, cosine, and tangent, and secant and all that. But anyway, we call that a secant. What's a secant? It's a line or a line segment that goes through a circle and hits the circle at what? 2 points, okay? That's a secant. So let's do, I'll tell you what, I'll change this to a different color. Now check this one out. What if, yeah, I'll keep the secant on there just to show you the difference. What if you had a line and it only hits the circle at 1 point? It doesn't go in the middle of the circle, in the center of the circle, or the inside, the interior of the circle. Let's scooch this up a little bit. It only hits the circle at 1 point. It just glances off of it. I got to click off that first. Okay? You see that? It only hits the circle at 1 point. Now, I don't have one, but let's say I had a ball or something and a ruler, and I put the ruler up to it, to the ball. It would only hit that ball at 1 point. Okay? It's kind of the same idea. You got it? All right, so this is a ruler, this is a ball. It would only hit that circle at 1 point. Guess what we call that? That's the tangent. Okay? So it's when a line, or you could say a line segment, intersects, we'll say intersects the circle only at 1 point. So, let's do this like that. Is that a tangent? It only hits at 1 point, right? Why not? That's right. It keeps on going. Because it keeps on going, it's eventually going to hit over here at this point, isn't it? So this thing right here, is that a tangent? No. All right. This is a tangent because it just glances off the circle. You follow me on that? Yeah. No. No. Well, let's do this. A tangent, did I say segment? I think a secant can also be a segment, but a tangent cannot be a segment. A tangent has to be a line. I may be wrong on a secant can be a segment. I think they usually define it as a line, but a tangent always has to be a line. All right. So if this started and stopped, right, you would say, oh, there's a segment that hits the circle just at 1 point. Okay, that is true, but a tangent has to do what? Keep on going. All right, it's got to keep on going. And if this thing keeps on going, it's eventually going to hit the circle in 2 spots. So this would not be a tangent. Good question, though. All right, everybody good with that? Now we got a couple things here. Let's change colors again. Do you see where it actually hits at that point? We give that a name. Okay, it's a point of tangency. Tangency. I think I spelled that right. All right, so that's the point of tangency. Everybody got it? So this is the tangent. The line itself is the tangent. The point is called the point of tangency. All right. I think that's all the definitions. Let me just make, yeah, tangent is a line. Yeah, in my definition, it definitely says a tangent is a line. It can't be a line segment. It says it's in the same plane. That's kind of almost given. We don't even think about lines and circles being in different planes, okay? So it's in the same plane, intersects at 1 point, tangency. A tangent segment, let's talk about that, a tangent segment. So if I said this was A, this was B, and this was C, what would a tangent segment be? The tangent segment would be from where? From, I guess you could say from C to A. But what they're doing is let me read the definition. Tangent segment of a tangent line that contains the point of tangency. So yeah, I guess you could say CA, line segment CA would be a tangent, or a tangent segment, okay? But what they do is they say that AB is a tangent segment, it's a line segment, and what else? BC is a tangent segment, all right? So it looks like they're kind of defining, they don't say it in the definition itself, but it looks like they're kind of defining the tangent segment as being the point of tangency being one of the endpoints of the segment. They don't really say that in here. It just says that it contains the point of tangency. So if you said line segment AC, yeah, it contains the point of tangency. So sure, that you could probably consider that as well. We don't really talk about the tangent segment very often, so I'm not even going to worry about that too much. All right, let's do some theorems. Everybody ready? Let's just copy this. Do you think I would put up with any of that? I don't know, man. I don't know. I'll tell you what, I'm gonna pause this and go see. All right, here we go. All right, let's see. Theorem. Okay, it says if a line is tangent to a circle, all right, then it is perpendicular to a radius drawn to the point of tangency. That was a lot of words, but I think that made sense. Let me try to draw. Man, something's in my eye and I can't get it out. All right, so I'm going to just drop this down a little bit so it looks like a tangent. That looks like a tangent right there, doesn't it? And I'll put lines. Sometimes I'm lazy and I won't put the arrows on the ends, but you know it is a line and it should keep on going, okay? So it says, if a line is tangent to a circle, then it's perpendicular to the radius. So let's find the radius. Well, where do I start? Start at the center. Now, do I want to draw my radius there? No, of course not. Where do I want to draw my radius? Yeah, it's going to be right there. Whoops, that's close enough. All right. So what does it say again? Let's say it one more time. If a line is tangent to the circle, so if they tell you that that's tangent to the circle, then what is the radius to the point of tangency, right? If I draw a radius to the point of tangency, right there, make that big old dot, okay? If I draw the radius to the point of tangency, what is true about the angle that's formed between the radius and the tangent? They are perpendicular, okay? It's a right angle. Everybody with me on that? Yeah. The converse is true as well, okay? What if you didn't know? Let me see. Yeah. The converse says if a line is perpendicular to a radius at a point on the circle, okay? So if you have a point on a circle, let's do this. Let's say you had a point on a circle. There you go. Everybody got it? And if you drew a line, let's draw a radius. There's a radius. And what if you drew a line that's perpendicular, let's try to make that to that radius. Okay, so here's a line. Yeah, it is kind of bad, but that's okay. Use your imagination. Oh, kind of like the thing itself is? Right. Because it says, let's see what it says. If a line is perpendicular to a radius at a point on the circle, okay, it's perpendicular to a radius at a point on a circle. So the line, if it's perpendicular to the radius at this point, then what is that thing right there? What is that line? It's a tangent, okay? That's all it's saying. Yeah, but you don't, because they didn't tell you it was a tangent, all right? But they say that this line hits this point and it's perpendicular to this. So watch this. Here, I'll give you a situation where it doesn't work. Watch this. No. Watch this. Here, let's do a different color. I know what you're saying. I get it. But watch. Look, that line right there hits the point of tangency, doesn't it? Okay. But it's not perpendicular to the radius. Agreed? So this one is not a what? It's not a tangent. But the theorem doesn't say anything about only hitting one point. It doesn't say it only hits one point. It says it does hit a point. It doesn't say only one point. It says it does hit a point on the circle, and that pink one does, doesn't it? Or that red one. That red one does hit a point on the circle, but it's not perpendicular to the radius. Therefore, the red one is what? Not a tangent. Okay? Is that a little better? So now, that's not so bad now, right? Let's keep going right there. There we go. All right? So now, if it's perpendicular to the radius and it hits at the point of tangency, then it's going to be a tangent line. Got it? I shouldn't even say hit at the point of tangency. I should say hit at a point on a circle. Okay? And it's perpendicular, then it's a tangent. All right, enough of that. Let's keep going. Everybody good so far? Yeah, we haven't really done anything spectacular yet. Let's do a example. I don't know how spectacular this will be, but this will be good. All right, so I'm going to draw a couple tangents. And I'm going to draw one about like that. Let's move that up a little bit. Then I'm going to draw another one. Oops. From here. And I'm going to move it so it's tangent right there. It's not bad. Okay. And let's find where the center is. That's an important point. Right there. This is example 1. And let's do this in a different color. And what I'm going to connect the point of tangency. Let's say the tangent is right there, and it looks like the tangent is right there. I'm going to connect right there. All right, now let's put some letters in here. A, B, C, D again. A, B, C, D. All right, and watch what they do. They tell you this angle right there is 3x degrees. So angle C is 3x degrees. They tell you that angle A is x degrees. And what you need to do is you need to find all 4 of those angles. Okay, so here's the information they give you. They give you all this stuff. They write a lot of this down in words. If you look in the book, you'll see it. It says, find the measures of each angle in this quadrilateral if AB and AD are tangent segments to OC. All right, they actually call it a tangent segment. So if you wanted, so it says AB is a tangent segment. So what would I do? I'd actually go to there, wouldn't I? And then I would take, oopsie daisy, grab the wrong thing. There we go. Did I draw it upside down? I'm drawing it the way it's in my notes. So I don't know, maybe in my notes I put it upside down. Is it the other way? Sorry. Doesn't. You're right. All right, so it's actually pretty easy though, once you understand what we just talked about as far as tangents are concerned. How in the world could I solve for x? If I solve for x, then I know this angle, and I can find the other 2 angles. Actually, I know the other 2 angles right off the bat. What are they? The right angles, because it said that these were tangent segments. Everybody got it? So AB is a tangent, AD is a tangent. What's BC? BC is a what? It's a radius. So what do we know about the radius and the tangent? They are perpendicular. So I know that's 90 degrees, and I know that's ugly 90 degrees. There we go. All right, so right off the bat, we'll just call it angle B. Technically, it's ABC, but you get the idea, right? So angle B is 90 degrees, and angle D is 90 degrees. We know that right off the bat. So how do we find the other 2 angles? It's stuff that we've done before. This is good. They add up to 360. Exactly right. So these 2 are already, let's just write it all out. So 3x plus x plus 90 plus 90, what do they all add up to be? 360. All right, let's do the math. This is going to be 4x. This is going to be 180. Subtract 360 and 180. What do you get? 180, right? Yes? Okay, and then divide by 4. X is, can you do that in your head? 45. It's not my answer, though, is it? Well, it's actually one of the answers, isn't it? It's angle A. So angle A is x, so x is 45, so angle A is 45 what? Not just 45, but 45 degrees. Very good, okay? And then angle C, how do I find angle C? I just do what? 3 times what? 45. What's that? 135? Is that right? Angle C is 135. It's as easy as that. So really, what was the only thing new about this? The only thing new about this was knowing that that's a right angle and that's a right angle. They didn't tell you it was. We had to figure that out because we knew this was a tangent, we knew that was a radius, and we know that they're perpendicular to each other. Yes? All right. Here's another theorem. You ready? I got to go quick because I'm running out of time. While I'm thinking about it, I will not be able to finish this whole thing because of the time constraints. So guess what I'm going to ask you to do tonight? Watch the video, okay? It's from last year. It's on there. Everything's good. I actually scanned through it just to make sure. Yeah, you'll have the homework. It's on the lesson. Didn't I give you a lesson plan? Yeah. Yeah. I already did, yes. All right, watch this. What if I have a point out here and I want to draw a couple tangents to that circle from that point? Everybody with me? I'm going to draw a tangent segment. Oh, I thought I change the color. There we go. All right, so what if I go from here, tangent, I don't want to go all the way here. I want to do a tangent segment, so where am I going to hit? Right at the point of tangency. Everybody good with that? And then I'm going to do another one, right? I'm not going to go all the way out here. I'll just go to here. Now, here's what the theorem says. And I bet you could probably look at it, just have a gut instinct, and tell me what's true about those two red lines. What do you think is true about those two red lines? They are congruent. Exactly right. All right. So if you have two tangents, okay, drawn from an exterior point, you see that point X? It's on the outside of the circle. If I draw a tangent to the circle from X and I draw another tangent to the circle from X, then what's true about those two tangents? They are equal to each other. So I can say that AX is equal to BX. All right? That's what the theorem says. You're going to use that quite a bit. That comes in handy a lot. All right? So keep that in mind. All right. And then they give you an example of it. Can I do this super quick? Let's do this really quick. Hold on just a second. I'll make this a little smaller. There's no math involved. It's just this. How many tangents can I draw from this circle to this circle? They got to be tangent to both circles. Well, let's see if I can. I'm going to have to. There's one. Okay. 4. That's right. Okay, but watch this. I just want to right there, and yeah, there you go. So these right here, I'm not going to write it down because of time. These are called exterior tangents. But then you could have what? Interior, right? So it would go like this, and I'd have to angle that about like that. So that would be one. And last one, these would be what kind of tangents? Interior, that's correct. So you can actually have 4 tangents drawn to 2 different circles, okay? All right, well, you got your homework, right? There's one more little thing on there, plus the example. The big thing I really want you to watch is example number 2. Okay, so make sure you go and watch the video and look at example 2. Just put it down there, it's good. Okay, everybody good? Yeah. All right, make sure you do the homework. I don't have it in front of me, but I just gave you a lesson plan, so you should know what it is. Okay.